Here I'm going to talk about Wireshark, and we're going to actually telnet to a free telnet site, which there's lots of them out there. I just picked this one randomly. But we're going to telnet to a free telnet site, and we're going to type a few commands, and we're going to get a few responses, and we're going to capture that information. Like I said, telnet is not a secure protocol. It was very popular maybe 30 years ago, but nowadays it's extremely easy to sniff the packets like we're going to do now. So without further ado, I will start the video. We're going to click the shark to start, and now it's sniffing traffic on my network. PuTTY is a telnet client tool that I'm going to use. Select telnet and put it in the site. I'm immediately connected up to it. So data has been exchanged. In the center here notice we have different layers. We have layer 1 through 4 in this case. And now we just need to pick a file name. No. We'll call it telnet 1. That's perfect. So in the first part of the video, I showed you how we made and saved the telnet 1 pcap.ng file. That's the Wireshark trace file. However, I also created telnet 2, which is what I'm going to give you for your homework assignment. So that being said, you've seen me create telnet 1. Now I'm going to open up the trace. The one thing you'll notice very differently and very quickly is nothing's running and nothing's stopped right now. There's just, I can scroll back and forth very easily. It's a small packet trace. So it's much more presentable, and it's easier to read. So it's very common to do a packet capture. If you try to read and trace a packet while the packet trace is going on, it's difficult enough in my house to try and do something like that at Albertus, and go ahead and try if you want. But you'll see how much traffic is really out there. So that being said, I'm going to show you a couple things with Wireshark. I'm doing this on the Mac. You can follow along. It's very similar on the PC here. So I wanted to demonstrate security first of all, versus non-security. So right now the TLS v1, actually there's more to this protocol than that. If I widen this up, you'll see. The TLS 1.2 protocol, you might have heard of that. We're going to talk about it a little bit later on in this class. But that's your secure socket layer protocol. So obviously you can see it says application data right there under info. So we know that this is an application layer protocol. So if I were to select this right here, you'll see I have 1, 2, 3, 4, 5, and it is even calling it SSL, even though the protocol is TLS. Those names get used interchangeably, but in truth, we haven't used SSL in at least 20 years now. So if we look here, it's showing that it's on wire. This is a clear example of my physical layer connection. I can expand this here. It can tell me some device information. It gives me the lengths of the frames. Lots and lots of information. Then here, Ethernet 2, it gives you the MAC address information to the destination and to the source. This is the switch layer. It's the data link layer. We can open that up there and get much more information from that. You'll notice right there it's got names kind of attached with it. That's because it's actually set to capture that right now, and I can demonstrate that in a second. The next layer is the IPv4 protocol. That's the That's the network layer, or that's actually the IP layer. The TCP layer is Transmission Control Protocol. So TCP, IP, that's where that comes from. And finally, we get to have the application layer, which is the secure socket layer that I was talking about. We can take a look in here. There's this header information. This is going to match very, very closely with what you'll see on your slides. Additionally, the slides will give you the header information for the TCP protocol. And it includes port information. You know, 443 is the HTTPS secure port designation. It doesn't have to be, but it usually is. So usually anything HTTPS uses port 443. And I don't expect you to get all this at once. Kind of go through it and learn. Take your time, learn for yourself, and review this and go back and forth. The secure socket layer is the application layer protocol. So we can look at that. We can see that it's using HTTP over TLS, which is what HTTPS is. We open this up here. We see the content type. We see the version of TLS. It gives length information. This packet here's got encrypted application data, so we can't make any sense out of this, which is the way it's supposed to be. So with this, if I were to go ahead and follow the TCP stream here, or follow the SSL stream, it's going to be, I'm not going to get anything here that I'm going to be able to see. And if I follow the TCP stream associated with it, I'm going to get gibberish. And you'll notice now also that there's very, very little here that you can see. That's because it automatically applies a filter. We can cancel that filter right there. These filters are really, really nice. When you go ahead and look at this right here, you've got these here are sequence numbers that you can go ahead and read, and that's what it's doing here. These times are ultra precise. And one of the queries that I like to do, one of the filters that I like to do is, if I want to try and filter out something with my IP address, which I believe the IP address I did this trace from is right here. I believe it's .70 here. So let's say I want to do that filter. I could do an IP .addr. It uses the equal as the operator. That means do comparison. So you're comparing values here. So let's say I want to do 192.168.1.70. And it turns green, so I know that that's a good query. Then I can hit this arrow to apply it. Now it's looking at the source and it's looking at the destination. So somewhere in the communication, it's only taking IP addresses that are .70. So the only packet information here is going to be something that has to do with me. As you can see, there's our telnet packet right there that we could do a trace on. Now remember, we tried to follow the SSL stream and it didn't look good. We know that this SSL stream is encrypted and it's protected. However, if we try and click on the telnet stream, and if I were to right click on that here and try to follow the TCP stream, I'm going to get the TCP stream word for word. And you can see who types what and who types it where. So one way I know that that was the telnet site we went to is it actually tells me the protocol. So how else can I know that this is my server, or this is my desktop, and that this is the server it's connecting to? IP addresses aren't real useful. I happen to know that that's me just because it's my network. If I click on view, I go into name resolution. Notice it's already set to resolve the physical address. That's why this physical address information here shows up. So first of all, why don't I unresolve that? And look at that. Now all of a sudden, it provides me just a bare MAC address here. So if I want to know and have the physical address resolved where it's going to do a vendor lookup, we will see this later on. It'll make a lot more sense. We can select that. We want to go ahead and look at network address resolution and transport address resolution. Now when you see that, I actually have names of my computer. I know that's my computer name right there. And I know that telehack.com is the site I telneted to do this testing. So there's some very, very good information here, which we will apply to the homework, and I will give you telnet 2, the stack trace